What word? Mean, because mean Mr. T. Are you ready to do a problem?
Yeah.
Alright, this can be started. I'm doing A and a B and a C and a D and E just like last class with their proportions. I looked through this morning, everyone. I like on page 449, number 34. So I'm going to write that down, everyone. This is in section 9.2. It's on page 449. We are going to do a confidence interval problem. I'll read it to you. This is in section 9.2. Okay? We're going to do number 34. All right. Now, Caitlin, I do want to point out the author said, just do this. We're going to make it like A, B, C, D, E out of this problem, so it's really clear. So I'm going to read some information to you. And we're eventually trying to estimate a what? A population mean? As we get numbers, can we write the numbers down off on the left side? Does that sound good? I think it's good. It's a good practice. You read a word problem, every time you see a number, you write it down in a symbol. All right, here we go. Tensile strength is the amount of stress a material can withstand before it breaks. Researchers wanted to determine the strength of a resin cement used in bounding crowns to teeth. Now, is anybody going in that field? I know, in dental hygienists, anybody going to do something like that? I'm just curious. Ooh, we already got one hand. But hey, they're talking about those crowns. Those crowns that the dentist puts in. So anyways, they're actually talking about the strength of that resin cement. I mean, crowns will sit for years and years in people's teeth. Sometimes they replace and put another one, but they can what? That cement, it can get, it can fall out and stuff. So they're going to test the strength. So the researchers bounded crowns to 72 extracted teeth. Okay, there's our first number. 72. All right, I write it. What is that? What symbol? What do y'all think? This whole problem is not about people, it's about their teeth.
Sample.
That's the sample size. And so we're going to give that a lowercase n. Does that sound good?
Mm-hmm.
Yeah, they're talking about teeth. We're like 72 teeth. So n equals 72 in this problem. It's the sample size. Hey, because we're dealing with t, I might as well write it right below it. Who can calculate df, degrees of freedom? I bet you can do it. 71, right? Might as well write it down, right? I know it wasn't in the problem, but we know degrees of freedom is always sample size by about 71. Cool. All right, so there's 71 degrees of freedom. Let me keep going. Using the resistance test, they found the mean strength of the resin cement to be 242.2 newtons. All right, so let me write that number down, 242.2 newtons. You can just put big N for newtons. And they said the mean. Well, when this isn't mu, this is that's the X bar. That was the mean of these what? 72 teeth. That was the strength. Newtons, everyone, they use newtons for force.
It'll be 242.2.
Oh, thank you. When I wrote 24.2. 242.2. All right, let me keep reading. Standard deviation was 70.6 newtons. So, all right, 70.6 newtons. Some of you don't even have to put the big N if you don't want to. I know it's not a physics class, but that's the force. 70.6 newtons force. They said standard deviation. Well, that's not this symbol because we don't know that. See, this is what? Unknown. So I'm going to use sample standard deviation symbol, which is, it's just a little s, right? If you don't know the symbol, you can write it down. You go, that's the sample standard deviation. All these numbers were given. All right. Now, eventually, everyone, they're going to tell you what kind of confidence level to do for this problem. 95% confidence, 90% confidence, 99% confidence. They're going to give you something. Here it comes up right now. Based on this information, construct a 90% confidence interval for the mean strength of the resin cement. So you and I are going to perform and construct a confidence interval, but it's going to be a 90% confidence interval. I'm going to write that down before I forget. Right? Cool? All right. Everyone, that number they gave right there is going to help us figure out t. But that's not t. We're going to have to read it from the what? Table. There should be enough information. Everyone see these numbers? It's not a crazy puzzle to us. With all these numbers given here, you and I will eventually pull out this sheet, and we're going to figure out the t-score to put right there, and I think you'll find it fairly easy. All right? Well, I'm going to get this started. Here's my first question, letter A. You know I did this last class. Can we verify the requirements for this problem? I mean? I mean, first of all, I want to make sure it was a random sample. And I'll be honest, when I was reading those words, I didn't hear the word random, did you?
No.
Now, sometimes it's really hard to get things done randomly. I didn't hear anything, I didn't read anything about this sample being random. So everyone, don't you agree that's the first thing we should look at? Maybe there could be, what if this was all done in one dental office? That's a huge bias, do you agree? I didn't see anything about this, but everyone, perhaps they just didn't include it in the wording. Maybe I should contact the author, ask about this, but how about we just assume it was a random sample? Does that sound good? Because if not, don't we already have bias?
Yep.
Huge bias. So well, we're going to assume it's a random sample. Randomization is the best defense against bias. Remember that in this course. Randomization. Best defense against any type of bias. I didn't see that word. All right. That's first I'm looking at as a mathematician, statistician. Second of all, do you know what the check is for means? The sample size, because we have no knowledge about the population, has to be greater or equal to 30. Do you remember this? And everyone, did you get a copy? Everyone got a copy of the sheet, right? If you know what that memorized, it's on here. It is on here. But the sample size, you know, it's conservative. We just want to make sure it's greater or equal to 30. Is it?
Yep.
So when I put a comma, I'm going to write that. We're good to go. Sample size greater or equal to 30. And assume that this sample is a random sample. We're good to go now, right? Have you noticed there's two checks? One of them is the n times the p times the 1 minus p is greater than or equal to 10. That's for proportions. What is it for means? N has to be greater than or equal to 30. And you can always look it up on the sheet. All right, so let's get the letter B. And when you need to now construct a 90% confidence interval. Okay. Here we go. Construct a 90% confidence interval. I'm going to set it up. Everyone, I'm going to write CI for confidence interval, equal sign. Oh, I don't have this memorized. You can look right off this sheet because it's on there. It's right there. And when I do want to point out on this sheet, I do have another one listed. Everyone have a copy of this? Can I tell you which one we don't need? The one that's all the way up in the top left. Would you just cross that out with a pencil right now? See the X bar equals and there's a Z there? That's this population standard deviation is known. You see that, Art? I want to see that in the top left. Okay, let's see that top left one where it says that. But see, population standard deviation is known. You know, that's not what happens in the real world, right? Let's put a line to it. Which one are we always going to use?
Unknown.
Smack dab right in the middle. So do you see it? Look in this top row of this sheet, right here. That top left equation there, Mia, cross it out. We're saying we're never going to use that. We're always going to use this one, which is in the smack dab middle. You see it in the middle of the sheet?
So the first one.
Yeah, cross out the top left one. And then the one in the middle is the one we're going to use. Sound good? Yeah. All right, here I go. X bar plus or minus, not Z, but T, S over the square root of n. All right, let's start filling things in. What's that number?
242.2.
Come on. You're good. Just fill in the numbers. We'll come back to the T, everyone. I'll put it in yellow. I'll highlight it. We'll do that last. What's the S?
70.6.
70.6. Square root of, what's the sample size?
72.
And when we are almost done with this confidence interval, we'll crank it out on a calculator. We have one little thing to find.
T.
You and I have to find this what? T. So get your T tables out or your T distribution out. Here you go. This gets attached to the test, right, Mia? Yep. Final exam too? Oh yeah. It's always available. First thing is we got to look in the left column at DF. DF stands for degrees of freedom. What DF are we looking for?
71.
71. Now, and if there's no 71, I want you to find the closest number to 71.
80.
Yeah, there's a 60 and 80. Does everyone agree 80?
Yeah.
Yep. So we're going to take the closest. If it was smack dab in the middle, it doesn't matter which way you go, but 71 is definitely closer to 80. Let's use 80. Now, we're going to move off to the right. What was the confidence interval?
90.
Now, look at the bottom of the sheet. Do you see all the percentages?
4.66.
See, everyone see the percentages way at the bottom? Denora, do you see those? Oh, cool. I need you to line up. You know how to read tables. Line it up. Be like, all right, what's the 90% associated with the, we're using the 80, right? So when we're using this table, we're going to use the 80. for the DF, we're gonna line it up with what's 90% confidence there, we're gonna line it up, and what do you get? I heard it. 1.664. Isn't that cool? By the way, if you look at the top column, what's the decimal associated with that? I want to show you what's going on here. 90% from the middle meant how much is in each tail?
5.
So there was 5% here in that tail, but what are these two t-scores? This t is 1.664, and what's this t-score? Cool.
So we don't do any more the inverse norm?
That's right. Isn't that cool? But who? I'm sure there's some students curious right now. And isn't it easy to find this from a sheet? Yeah, no one's gonna have trouble doing a sheet. Now, I do get people who go, yeah, but come on, this is the year 2016. We've got technology. Can I do this with a calculator? Well, who's got a TI-83? All right, TI-83 people, you need this sheet.
Oh.
You don't have an inverse T button. Who has a newer like TI-84 model? All the new models have an inverse T button. So if anybody didn't feel like looking at the sheet and wanted to get this off their calculator, they'd have to inverse T, and when this is what you do, this would give you the t-score. So when t-score would equal inverse T, you'd have to put in, what's in that left tail?
0.05.
0.05, but then you have to put a comma and you gotta list the degrees of freedom. So how many degrees of freedom did this have? You just go like that. Now I'll be honest everyone, you know I have a graphing calculator. My graphing calculator doesn't have the inverse T on it. Isn't that funny? You know, I can go to the math department and complain. Hey, where's mine? No, I'm fine. I'm fine. Just I used a T table, right?
Where's the inverse T?
You might not have it. Did you go to distribution?
Oh, no,
Go to distribution menu, just like inverse norm. It might not be there. It depends. Some have it, some don't.
Oh, yeah.
I don't have it. Do you have it?
Yeah.
Give it a shot. Tell us what you get. And when I can't put it on the big screen because you know what? My calculator doesn't have it. That's okay. We use the table. Everyone like you with the 83 is old school. It's no problem. I can read a table. I'm not going to go buy a whole new calculator just for this one what? Inverse T. You could probably download it off the internet if you want. But I'm like, oh, this will work. This will work. Who's stuck like me with the table? Oh, good. Now, if you want to use calculator and get that inverse T, you can. Just don't forget, hey, you got to put the comma degrees of freedom.
Yeah.
Because it changes depending on the sample size, right? Good job. You have it?
How did you get 1.664 again?
Okay, so when we looked at that sheet, we looked in the left column for degrees of freedom. We saw the closest number to 71, which was 80. Then we went over to the right, and we looked at the bottom of the sheet where it said 90%. At the bottom of the sheet, we lined up 80 with the 90%, and we got the t-score of 1.664. I do want to point out, if you look, Preston, at the top column, then you're going to have to look at a 0.05, because that's what's in one tail. So that's why it's easier to look at the what? Look at that bottom, because it just tells you.
The calculator gives you something different. Well, not a lot, but it's like.
Oh, she's right.
1.6.
The calculator's more accurate. Tell me what the calculator said.
So, like, for example, since I take the test on, the computer.
Oh, you're going to be fine.
that-
Because think about it, you got a lot of students like you who are using TI-83s. So that's going to be fine with this number. But hey, tell the class, what number did you get when you put this in there?
Negative.
First one's going to be negative because it's going to be on the left. But negative and positive, it's symmetry, they're going to be the same. And what did it come out to be?
Negative 1.6665.
So look, it was very accurate to at least 2 decimal places, which is fine. But you're going to be fine because they know that. The programmers of that know that probably at least 50% of the students, if not more, are using TI-83 calculators. So you're good to go. Good question, though. Plus, a lot of times, you're going to notice in the My Stat Lab, they provide a table. You only even have to have this next to you. They'll be click on the distribution table, and you can get it off the table.
Do they have
It's a
this
great
on,
question.
on TI-92?
TI-82 has it, yep.
They have it.
Yeah, all the new ones.
I'll look.
It's just the old 84s and the old 83s.
Sure.
Well, 83 being old, yeah. But I have an 84, everyone. You see it up there. Mine doesn't have it. I'm curious, who had it? Denora, you have it? Randy has it? Look, it's less than 10 students. So can you imagine this? I have some colleagues who think every student should have to have these new calculators. That's a lot of money, isn't it? You think it's worth it? You go spend $140 just because
Just for
you don't?
one function.
I think this is a little bit cheaper. Do you agree?
Yeah.
Oh, me?
Yeah.
I'm with you. I'm with you. All right, I'm gonna erase all this, everyone. Let's find this number. So get out your calculator. I want you to find this number after the plus minus. And you and I will be done with the confidence interval. 242.2 plus or minus, what's this number though? And you know, we'll got to like one decimal place. What do you get when you go 1.664 times that? I'll do it too. Only takes a second. I just want to get that. By the way, do you remember what we referred to after the plus minus? What's the name of this? Everything after the plus minus?
Margin of error.
Margin of error! Thanks, Art. Cool. Alright, here we go. And I just want to see what the margin of error is. What's 1.664? Denora gets to write hers more accurately with the 1.666. I know. 1.664 times 70.6 divided by square root. Whoops. Square root of 72. You don't even have to close out the parentheses right there, but I'll do it. Looks pretty. Alright, what's the margin of error?
13.8.
And they're really newtons, so you can go 13.84 newtons. 13.8 or 13.84 newtons. I'll hit the lights. And when there it is. This is the what? Confidence interval. And yep, everything after the plus minus is the margin of error. Do you remember I encouraged this last class? I encourage everyone to write the confidence interval in two ways. So I'm going to do it now. This is one way. This is full credit. That's your confidence interval. But I'm going to put or. I encourage you to write it like this, as an interval. And it's very simple. All I have to do is take this number and subtract that, and take this number and add that. I'm going to do it with my calculator, okay? So I'm going to hit the lights. I just want to see what these two numbers are. All right, what is?
And it's from lowest to highest?
That's right, you always go lowest to highest. Always go from lowest to highest. So what's 242.2 subtract 13.84496221? And what is 242.2 plus 13?